Hey guys. Alright, so today we're going to implement this quicksort algorithm that we talked about in the theory lesson a while back. So I'm going to knock the code out, and then we're going to go through it, and I'll have some notes for you. Those notes will be posted to the GitHub. So yeah, let's get started. Alright, so let's do the quicksort. Alright, whatever we pass, it needs to implement order. And so first we're going to define a length for the base case. Alright, so if the length is less than or equal to 1, we know that beside is sorted, right? Then we'll do our pivot index, which will come from our partition function, which we'll define in a moment. And now we got to recursively sort each side. So that's what this is going to do, right? And I'll explain the syntax to you. There. All right, so this is your left side, and this is your right side. All right, and so you can see here, right? So this is everything less than the pivot. This is the pivot plus 1, right? So the right side. And then, you know, we're doing each side, right? Just like we talked about in the theory lesson. Each side's being sorted individually by itself. All right, so let's do partition. It's going to have the same method signature, which is nice, but it returns an address, so usize. All right, so now let's do the pivot. So in our case, we're just going to use the last the last element in the array, like we talked about, for ease. And then we need to define I. All right. So I is going to be the boundary, right? So it's basically going to track the index where the next smaller element should be placed. Okay, so every element before I is guaranteed to be less than the pivot, right? So I'll show you. So let's get in. Let's get into the loop, and then during the notes we'll go more into it, right? And then I'm going to go ahead and return I down here to get rid of the squigglies. And then yeah. And then gotta increment I because it's keeping track of the boundary, and then do another and then this swap down here, this is going to place the pivot, right? The last step. Okay. All right. So we will let's see what this thing looks like right quick. That's it, guys. 26 lines of code with spacing and everything. So let's see what this looks like, and then we'll look at the notes and we'll clear everything up. All right. So I've already got an array defined. It's out of order. It's just a mutable vector, and then so we're going to do quicksort. We're going to pass array, and then remember everything's in place. So we don't need any extra storage. We don't need to find another variable. We should just be able to print the thing out. And let's see what this looks like. Well, there we go. So we have 4, 9, 10, 27, 38, 43, 82. All right, so we are in order. We are successful. All right, so now let's go back and look at the code, right? So let me pull up these notes here, and we can see what's going on, okay? So quicksort. All right, so as I mentioned, the function signature means that the type that we pass, it has to implement the order trait. Okay, so any type that can be ordered, which makes sense. That's what we're doing. All right, and then we take a mutable slice of t, so it does the in place like we talked about, right? So then we have the base case. which is defined here. So if the length is 0 or 1, then our elements are sorted, and there's nothing left to sort, right? And then this stops the recursion. Okay, and then we have the partition step, and so we'll talk about that below in the notes. And so this reorders the elements so that everything less than the pivot is on the left and everything larger than it's on the right. Okay, and then it returns the index. That's what it's returning. It's returning the index where the pivot's located. Okay. And then I kind of talked about this when I was running through the code, how this is set up, right? So we've got the left side, we've got the pivot, and then we got the right side, right? So basically after the partition runs, we have, 3 sections, which we talked about in the theory lesson. So as I mentioned, this is sorting the left partition, right? So this slices everything from 0 up to the pivot index, non-inclusive, right? So in Rust, slicing means that you start at the first element, you go up to the last element, but you don't include it, right? So since the pivot ends at pivot point, the left slice, it excludes the pivot, which we need. The pivot's its own thing, right? So sorting the right side, same thing. Pivot index is already in its position and it should be skipped. And so this means that the right partition is everything after the pivot. Okay. So now let's go into the partition function, right? The loop and all that. I hope you guys like this new format of notes. I'm trying this out. This is different than the format that I had for the linked list method, for the linked list, and so implementation. So hopefully, I'm trying to make them a little bit more succinct and more granularly kind of explain the code. So hopefully you guys like this. You guys like this new format. Okay. So the first thing we do is select the pivot. And also, guys, as you're learning this stuff, as you're learning the code, think about the steps, right? Think about, selecting the pivot, initializing them, like all these steps that you go through, and that's going to help you reason about the code and be able to, memorize it, remember what you're supposed to do, right? It's about remembering. It's about remembering the algorithm and not about memorizing the code, right? So first thing, of course, we got to select the pivot, and in our case, we're just selecting the last one. Then we're initializing the right. So like I said in the video, or like I said during the code, this will track the index where the smaller elements should be placed, right? So elements before I are all guaranteed to be less than the pivot. And then, okay, so looping through the array. Okay, so this is the core bits. So we compare RJ to our pivot value, right? So if RJ is smaller, we swap it with the element at the I boundary, right? And then we increment I. So the idea here is that over time, I separates all the smaller elements out, right? Now, swap. So swap is a standard library function. It operates on slices in Rust, right? So it exchanges elements at indices A and B in place, right? Without creating the extra allocations, which is the whole point of the quicksort. And you guys, you've probably seen code like this, especially like, old school C code. So yeah, a pretty common pattern under the hood. Yeah, and then at the end, we place the pivot in the correct position, right? So after the loop ends, the pivot element is swapped into the I index, and then everything before I, like we said, right? Everything before I is guaranteed to be smaller. So everything after I is greater. And then we return I, which is where the pivot ends up, right? And that's why it's used up here, right? So remember, this is storing the pivot index, and then we're using that index to partition off the divide and conquer, or to do the divide and conquer. So where was I? Oh yeah, okay, so now theory relation, okay? So divide and conquer. So we divide the array by picking a pivot and partitioning around it, and then we recursively sort the left and right, which we've been through, all right? And the in-place sorting, which we talked about in the theory video. And then, of course, the performance, right? So if the pivot splits the array roughly in half each time, we get linear arithmetic. If the pivot happens to be the smallest or largest element due to just an unlucky pivot choice, the partitions become unbalanced and we risk, that quadratic performance, which we have talked about. Yeah, and so down here, what I'm doing is I'm kind of going more, I'm breaking down the partition method into more steps and kind of clearly going through them. So you guys can look through these. This is just kind of a reiteration and more kind of a more granular look at the loop as compared to, up here when I go through it up here. Okay. So yeah, guys, so that's it. I wanted to keep this video shorter. The other video's been running kind of long. So yeah, look through the notes. Let me guys know if you have any questions. Help each other out in the comments. Ask respectable questions and you'll get respectable answers. And I will see you in the next video. All right, guys.